Record too. I'm gonna.
Yeah.
Is that okay? I'm just gonna record the screen. No one's recorded.
So I remember Rana, right, mentioning about it, where like if you sit into the car, maybe scanning the emotions of the, let's say, an Uber driver, right?
Mhm.
How safe it is. So where has that research progressed?
A lot of different places. I mean, that's also part of Smart Eye's focus. So the company that
Yeah.
acquire us, that is like their main focus is
Car.
interior sensing, driver behavior monitoring. They have a few different product lines around that. So I can't exactly say where their research. I mean,
She
it's
was pleasantly
progressed.
surprised by her expression from an AI neural net.
Yeah, no, it really has gone in a lot of different
Yeah.
directions and in understanding that. We work more on the research side of things, let's say with like product development for different car manufacturers, so like understanding how people are navigating in the car. How can they find the buttons? Can they, like, what is the user experience of using a car? Is it a stressful experience? How comfortable are the seats? How is the sound? Like, it really ranges and how the
Have you
technology
guys?
is applied.
So StarCraft Deep Mind. Like, so they have a Alpha Star, which literally is AI playing a video game. That's super intensive. You're controlling 200 armies, collecting resources, constantly trying to offset each other with little small attacks to get their attention off it. But DeepMind from Google developed Alpha Star. But it'd be interesting to watch the top video game players and capture their emotions while they're playing.
Yes,
People are doing that.
Yeah,
Yeah.
that'd be so cool.
Yeah, on the commercial side, we work with a lot of clients, but lots of NDAs in place around what we can. But we are working with different
That's cool.
gaming type of companies.
So here what you're seeing is a very common multimodal type of setup.
Yeah.
So facial expressions, wearing EEG, there's even EMG here,
And that's
which is
capturing-
muscular changes in the
Nice.
face.
Yeah.
And then you can't see it, but she's also wearing a device on her hand that's measuring her galvanic skin response. So really the takeaway here is the capability of knowing exactly what happens at any point
Mm-hmm.
in all of these different types of physiological
This is your project for med
metrics
school.
while she is watching this movie. And so you could imagine doing this in a clinical population where you're comparing depressed people to anxious people to controls when they are watching something about being traumatized, for example. And then capturing, okay, how are they responding differently in all these different metrics? And in fact, when these people show, let's just go again back to this neutral face, when they're showing a neutral face, they're actually showing a heightened physiology in a bunch of other metrics, but we just can't see it on their face.
That's cool.
And so there is either a suppression or perhaps some kind of dysregulation there that you can then dig further into, right?
Yeah, and so there's a lot of eye movement therapies, right? Like you look left,
Yes,
right.
EMDR.
But like, so if you do EMDR in a walking environment, I found it very useful.
Mhm.
You go into a flow state, so like you're forced to walk because you have to balance and everything else. And if you have a therapist next to you, my dad and I are running. But like if you're like just walking, you tend to open up and go to a deeper level of penetration. I'm talking about lots of topics, not even trauma, but just like topics in general.
Yep.
And you're not thinking about it because you can't because you're walking. If you're trail running, we find it even more fascinating. Like trail running and talking, like your mind goes to these places that's just like
Yeah.
because you have to like pay attention to every little thing and not trip on roots.
Right.
And by doing that, your mind just like opens up.
Yeah. We have people that I
can't follow the sensor on me when I trail run, but if I could, I would do it right now.
Yeah.
So like let me know if you want to experiment. I will put it with my dad and I in Austin, Texas.
So this is an example. We can also annotate the data.
So
And
my
try
question
to...
is, she's watching that video with these balls coming, or is this
These are her eyes. This is where she's looking
She has
at.
4 of them? Jeez, I wish I had 4.
No, so just one at a time, but it's just
That's her
moving
path.
around. Yeah.
Oh, that's so cool.
So I could just...
So what she thinks is important, right? Like, or what
Here.
pops on her attention scale?
Yep. So what is it she's paying attention to as she's seeing this advertisement?
Have you thrown a ball at someone while they're doing this? Like a
Um,
tennis ball? Like, again, people will protect themselves in a risk environment, and they'll move around. Even if you're just moving around dodging,
Yeah.
you'll tend to focus on the most risky item.
I don't remember anybody here in the office that has done that more recently. We have people that did it with golfing, and like what was people looking at in that perspective. But yeah,
Throw 10 tennis balls at someone, and they're going to avoid one of them.
Huh.
Which is the one they never want to focus on, right?
Yeah.
So this is what it looks like, and then you can aggregate the data. You can do areas of interests.
Cool.
Do you want to show maybe the areas of interest just to
Sure.
get a sense
Yeah.
of like what that?
So you can do areas of interests are, when you want the eye tracking data from a particular region of the screen that you're most interested in. It becomes more challenging when you have a video, of course, just because everything constantly changes. So then you can do dynamic AOIs, but it's just having a difficult time loading. But you can see, you have to move them manually. So you can do it again, so that when you go here, it pops up again. But it's a lot if you want to keep on moving it, if whatever you're looking at is moving. So what we can do is that we have an algorithm. I'm not going to show it right now, but basically it's called gaze mapping. And what it does is that you can take a particular object or scene from a video. So let's say they're watching a movie and at one point a woman appears. And then you can take a picture of that woman. That's a very representative of what she looks like in the video. And then you can tell the algorithm, I want you to map this picture of this woman onto every frame in the video. And every time she appears, I want that eye tracking data to be placed on top of her face.
Oh, cool.
So that you can actually aggregate the data. So even though you do have a video that's dynamic, you can then basically treat it like static data. And so that's
Did you put
what
the
we did.
AOI on her gaze spot? No, not yet.
Yeah,
On-
no.
On her, yeah.
So here, for example, is a scene of a frog that's moving.
Mhm.
Oh, so that's a scene. Let me go to the gaze mapping. So here you can see this is a static image. It's not a video where the frog was moving. And then you can go in and do an area of interest. And then you can measure, okay, how much did they look there compared to, let's say, for example, right here. And then you can compare those two metrics. And they just come up right here. We have a ton of different metrics though. So this is just some of the more popular ones, but you can choose whichever ones you want here. So typically the ones people are interested in are things like revisit count. How many times do you look back to the frog, for example, or to the same ball, let's say? What is the time to first fixation? So which area of interest first pops to your attention? Which ball do you first look at? And then dwell time. So how long do you keep looking at this item? How long do you keep looking
Which
at the
for
same
product
ball?
research is like gold, right?
Yeah,
Let's go.
exactly. And so this is, and it's not just for product research. I mean, also for evaluation of like people with depression and autism will have a very different gaze path compared to someone without depression or autism. And so it's actually so different that you can predict whether or not a person has autism or depression based on how they scan over a face. So
Let's go.
that's very powerful, right? That's just one metric.
Right.
Imagine
Yeah,
if
so
you could
my-
then combine it with
Everything
other
else, yeah.
physiological, which you can.
Yeah.
Yeah, and so my sister's kid is not starting to talk. He's like 3,
Mhm.
and he's like says little things, but he doesn't feel like he needs to talk.
Mhm.
He's like ball and mouth, or like he'll say stuff, but like we have to try it. And the
Mhm.
parents are all upset. I'm like, he's gonna maybe develop this on stage, but like if you keep on like making him feel like he's incapable, like that's not the right path, right?
Yeah.
So they're going to like speech therapy coaches, everything else, but like something
Okay.
like this could just like totally open the world. Like, what's the right communication method for the kid?
Yeah, something that is starting to pop up that I really like are all of these video games that are geared both to kids, also to adults of all kinds that are interested in just having games that are useful for your cognitive function. So not necessarily that's like making you talk, but just like training your cognitive capabilities, right? And so obviously when you're doing crosswords and all that, like it's happening there too, but these games are just really designed to do that.
It's a
So.
Perception.io, or like there's this one game, like Elon Musk funded it or something, but basically it's a game for children, and it like literally has no rules. You got to figure it out, and it's like pretty tough. Like they
Oh,
come
I've
up with
heard that.
challenges, and
Yeah.
it's like Link
Kids
just
are
showed
great
me.
at that.
Kids are really good at it, and they're trying to identify future developers.
Yeah,
And
based
like
on that.
people, just based off of that.
I've heard of that. Yeah,
and
yeah.
it's like, imagine if you could record them
Yeah.
here as well.
There are some really cool things in fMRI that are happening. So fMRI is functional magnetic resonance imaging, where you can actually scan the brain
In real time.
in real time. Yeah, and then you can also show them a video, and so that can be a video game where they have to control a particular ball with their brain activity. And so there's again no rules to it. It's just like give it a shot. Try different things, and then at one point you'll figure out the rules. And so you can actually see how they can transfer between different brain states and that
Quickly,
way you can change the ball, and so they can give them this
Make the
task
ball
of-
bigger.
exactly,
Yeah.
and
Let
then
me think about the ball being
exactly, and then it's like, okay, and you can only make it bigger if you activate the areas of your brain that are associated with being happy and content. Let's
Yeah.
say.
bigger. It's like
So
Peter
it's
Pan.
really
Peter
cool.
Pan flying. You have to be happy.
Yeah.
Oh, shit, I'm falling.
Yeah, so that's really cool, and that
Oh.
we do have capabilities here to do to use APIs. So that's a way for different systems to talk to each other. So let's say you have a custom-made algorithm in Python that you wanted to apply to your study. You could actually do that, and so that way you can integrate biofeedback. So let's say you have people that are looking at a video, and every time they're not looking at a certain element on the screen that you want them to look at, you could actually have a little box coming up and say, hey, remember to look at this. Or it could be a biofeedback where they're watching the video, and whenever their galvanic skin response or heart rate increases above a certain level, you get a biofeedback saying like, hey, remember to relax,
Yeah.
Take a deep
So
breath.
yeah, so that's also something
That's huge for, I mean, like, just things that I'm thinking of, like, what if you had something that just monitored your activity, and there's no recording going on, but it's real-time feedback. It's like, you're under stress. And
Yeah.
like, it pops up green with the green tree of life or
Well,
something.
that's
Or, like,
what
there's,
they're-
like, how do you
that's
just
what they're
relax people
trying-
through awareness?
Right.
Yeah, and that's what they're trying with the Fitbits and all of that,
No,
where
they're
it's
not
like,
working.
take a breath, but the problem is it's not that accurate, right? And so getting this technology that's highly advanced into a wearable is challenging. It's something we
Yes.
are working on.
But even a camera at your thing that's always on, but as long as it's not recording, again, it might be using the algorithm, but something that's like, oh, you just had a stressful call, your tonation in your voice, which I don't know if you audio.
We are getting there.
Yeah.
So
but if you
it's
did
coming
voice
out. the
plus
speech
facial
system.
expressions and like you're really stressed, what happened
Right.
in that call? Oh yeah, someone
Mhm.
told me my flight was canceled. Oh yeah, that's gonna spike your
Yep.
call.
Yeah,
But
and
then,
that is
then
where.
what do you do to like meditate right away? Like
Right.
go walk in nature, come
Yeah.
back when you're ready.
Yeah, and that is where the whole field's headed.
Right.
Yeah.
No
right.
doubt about that.
And our place within that field, though, is more supporting
The
research.
companies, yeah.
Yeah.
Right. So, because we're not going to be in a place where, like, we'll ever put out a product to
Well,
do biofeedback in a certain way. Like, we'll
No.
enable biofeedback, but we're not going to say
But you're
what
the platform that's
thresholds
behind
are.
hopefully all of them. Like
On a
if-
research side
on a
of
research
things.
side,
On a
right?
research
If
side
people
of
want to
things.
productize it, they do their thing. But like they have a research organization that ties to your research, and then
We need the algorithms to come out first.
Yeah.
So the facial expression algorithm was developed by Affectiva.
Okay.
The voice analysis will never be a place where you do in-depth voice analysis.
Mhm.
But if someone comes out with a product that's high quality voice analysis, that's currently the issue. High quality voice analysis that's easy to use for everybody. Then that's something we could put into iMotions.
Right.
But right now that doesn't exist.
But
so we're
but,
waiting.
but there
for that.
are like off the shelf NVIDIA and some other tools, and the thing is, you get somebody who's a little familiar about like voice, and all of a sudden you can make that like you use their tool to do your research,
Yep.
and you use their tool to do your research, and now you
So-
have the best next gen like voice
For sure.
analysis tool.
Right.
The way you can do it and where we're going, so we're going towards something called speech to text.
Mhm.
So just you're capturing everything they're saying, and then some general evaluations of was that positive or negative, their intonations. But then it's also going to be possible to get a segment of the audio, or get the whole audio file, so you can record what they're saying, and then you can extract it, and then you can do your analysis in platforms that are developed for that.
Yeah.
So there are certain platforms, Audacity and Pratt, that are developed for doing high quality peer review level
Yeah.
voice analysis. And so then, but again, it's really more for academics, and what we're talking about a little bit more now is user friendliness for people that want to integrate this technology in
Yeah,
their
that's
everyday
for
life.
sure.
But we're getting there.
Yeah,
We
and-
just need people
and
to
the
do
tools, yeah, to people to do the research, and the tools initially might be only for 5 people, and that's
Yeah.
okay.
Right.
But how do you expand that 5 people and the research around it to get to the next 5 in
Mhm.
half the time or a third of the time?
Right.
And then you just like it might be all HBAP that's interested. I'm pretty sure if you gave us all the hardware and costs for it all, we could figure out a way to pay for it and then have our whole community tackle this shit.
it. That would be great.
And I want something at my desk that's like, that's just not even positive, negative, but like, are you agitated or not? Like an agitated metrics, just
Yeah, but that's-
shine red or something.
Yeah, positive, negative is much more neutral. Like it's
Yeah.
much easier for an algorithm, right? Because are you agitated or are you mad?
But maybe,
You know?
maybe it's like positive, negative, and I say I have 3 options: I should, mad, or whatever, and I just select it, and then I tell it the answer, right?
Yep,
And then
and
over
that would be
time-
the best way to do it.
learns.
Yeah.
Yes, that would be the way to train the algorithm.
That'd be cool.
So yeah, if you could do that, that'd be great.
I also want to be conscious of your time, Penny, because I
Yeah.
know you have another meeting in a bit. But how has this been helpful to see?
Yeah. So
some of
how
the
do we
stuff
get?
that we're
Well,
gonna
how do I
understand?
get personally access to the platform? What's the fees? But also the hardware. What does that
So
look like?
it really does depend. Our solution is priced on a modular basis. So some people will come to us, everyone's lab's different, right? So they'll say, oh, I want facial expressions and screen-based eye tracking and skin conductance. So the software side of things are priced on an annual subscription.
Mhm.
So if you said, I just wanted facial expressions, there's no hardware needed for that. Hardware ranges from $1,000 to $100,000.
EKG.
Like,
What's the highest, most expensive?
well, we work with some high quality eye trackers that are
tracking.
like
Ah, okay.
$75,000 for just a
Because
two-camera
they're getting
setup.
like very pinpoint location.
Yeah.
Yeah.
So it really is a range, but let's say you wanted a basic setup, it would probably be about $40,000 for a solution.
And then camera only. That's pretty much part of the software, right? You just
Yes,
get your own
you could
camera.
just use a normal webcam, like even the one that comes with my computer
Yeah.
will be sufficient.
But again, that's multiple sensors, right?
Yes, that would be multiple sensors. So facial expressions is just one sensor, so it's 2 modules and then no hardware. So I think that annually is around $10,000 to start. So it's not, crazy, right? And it's unlimited number of participants, videos. Like we don't cap any of the amount that you put through iMotions. It's just the process is what Penny had walked through today. So it's not like it can be embedded in an app. You would have to download those videos and then process those in iMotions.
And that's I think that's fine for me for now. But what I'm thinking is like, can we get people in our community, like let's pick 2 or 3 use cases and all as a team tackle it on our free time, a few hours a week, and all of a sudden we have 1,500 people tackling the problem together and just unlocking potential of the platform. And then we're like, then I'm on the ed tech side, like, hey, do a debrief of your class. What was good? What was bad? And I record that. And it's like I get that to the teacher.
The one thing to mention is that with iMotions as our desktop platform, all of the data is stored locally, so it is PC based.
Oh, yeah.
So depending on where people are, it would have to live on
The PC.
on the PC, and we do that for a number of reasons. Most of the sensors, like connecting hardware, are also PC based, so it's stored there, and privacy.
Data
reasons.
privacy.
Yeah.
That's what I'm getting with the hardware. Like my goal for some of these is like store your video on your phone. If you want to revisit your video of yourself, do it when you want. But I don't want it. Like, I might run it through the thing, and here's a timestamp of your video with what you exactly showed me. There's no audio or something, or maybe there's no audio, right? But like then you can give a timestamp and an expression of that video that's local, and then someone can access that on their PC, right? That's
But couldn't the video be then sent to cloud or whatever your account, and then multiple people, like that is for your customer to set up, right? Your
Yes.
setup sets it, records it on your own device, and then what customer does with that data, it's up to the customer.
But
right?
they would, the customer would have to have someone process it on the iMotions PC. So if someone sent the videos or you had a file structure that works, you could just process it within the iMotions computer.
How big is that file of that video with all the
You
things?
can't do more than we have had people try to do a 1-hour recording where they also looked at websites and stuff.
Yeah.
And then you're gonna have issues with loading it. It's
Well, yeah,
just
because of
gonna
the
get
video.
too big
But
as
if it was a video
file.
of me only, and you just say you get rid of the
Oh,
video, and you just take the analytics and I timestamp it, and then I use my PC's video and play back it with this time.
You'll want the real video. We will want the raw video,
Gotcha.
like that you sent us. But
No, I'm saying you'll want it, but when I want to access the results of that video,
How
like
big
all
is
I
it?
want to see is anger and fear at the timestamp.
oh
of
yeah,
where
it's
like,
just
how big is that file?
You can open it in Excel. It's
Okay.
it's not gonna be big at all. And you can see we shared with you the different Excel files.
Because that's what I think
That's
if you want to
associated
transfer
with
anything,
it.
you transfer that. It doesn't have any
Mhm.
context. You call it video 1 and say, hey,
Yep.
on the phone, that's the video I sent you yesterday.
Right.
Yeah.
Sync it
But that's
locally.
just an Excel file, and
Yep.
that we
And it's
shared
really small.
with you.
I mean, compared to
Yeah.
Oh yeah.
Yeah.
I mean, the longer the recording, the longer, the bigger the file, right? But you can do this with an hour-long recording. The problem is, it just takes a long time to process it. So, and the export will take longer, but really the longest thing is for the processing of the algorithm that's going through it.
Yeah.
to look at the facial expressions.
Have you deployed to GPUs so like you can process it faster? Or everything
We
in each
do
pod?
that with the eye trackers, but you know, you can try to do that. We don't really, I don't know of any clients that do that, but that would be worth giving a shot.
Yeah, it takes about as long as the video in length to process it. So if it's an hour video, it was like an hour to process, maybe even a little bit more. And again, we have recommendations around certain hardware specs, but you'd want to have the bare minimum.
Yeah.
And the way this captures the emotion of some sort, is it per frame or like milliseconds? So
Per frame.
Per frame.
So for each frame, you'll have a data point.
And the back data, is it like, okay, 1 for that frame for
Yep,
fear,
and
for
you have, so
Right.
for when you're using the threshold at our notebook that we've developed, it's binary. So it's 0 to 1, like is it present or is it not present? But you can also get the raw data where you can actually look at like the intensity profile. So like from a scale from 0 to 100, you know, like how intense was it?
So you can use like Bayesian like level thinking, like, hey, what's the probability of being
Yes.
activated or not?
Yeah.
oh, so actually 0 and 1, and then intensity also.
Is the raw
That's
data
the raw
behind
data.
it?
Yeah. But the intensity, you know, always be careful
It's a
with,
set point.
Yeah.
So if you're
be
sensitive,
careful with interpreting that as being like, actually there are, this person is more intense, emotionally expressive than another, and then correlate it with what they actually feel. That's why we have done the thresholding thing.
And that also is why we do multimodal, right?
Yes.
Combining that
You-
with some of the eye tracking information, combining with heart rate or skin conductance. paints
That's
a
really the
more full
power of the platform.
picture.
Yeah.
Yeah.
have you had anyone do processing like you have your natural set points and then you have a super sensitive one on like fear, for instance, and then like having processing.
You have to have the same threshold for all of them,
Okay.
but what you can do is that you can create multiple different analyses.
Yeah, that's what I was gonna say. So you can do one under the
Yes.
all the set points, which is really sensitive, and one
Yeah.
that's normal.
So you can
Yeah.
see here I have 4 different analyses, and I could have applied a different threshold to each
Yeah.
of them.
Yeah.
That's cool.
So that's totally, and that's something we really highly encourage people to do, because it's a really good way to just get an understanding of your data. You know, like how does it distribute when you have different thresholds, and what is the optimal for you in terms of the particular facial profile that you're interested in?
Right.
Yeah.
Cool.
I mean, there is a lot of flexibility in how we can present information for you, right? Like even the raw data, the replays, so much flexibility in how those outputs look and what you can do with them. And then there's a lot of flexibilities on the type of research that you can
Yes.
conduct. Like
Yeah.
we could spend days talking about
So-
the different use cases that clients are kind of
Yeah, no, it helps a
working
lot.
the platform.
If we wanted to set up like the equivalent of sending in a video and analyzing your own data, like do you have like here's the recommended easiest way to get to the data and start analyzing it? Like, do you
I
have like
mean-
a training?
So that would be the customer success manager that would work with you and say, this is the recommended study design, here's the workflow you would suggest. So it's a 2-part onboarding. First part is more focused on like setting up studies, what does that look like, connecting, calibrating sensors. And then we usually ask you to do a pilot project. So maybe design an experiment, capture data from 3 to 5 participants. And then the second onboarding session is devoted to the analysis. Now what? How do we generate insights from